Hi, so now I'm going to start talking about applications of integration. So you see this, there you go. So for example, here you're going to have this F curve, okay, which is the black one, and the G curve, which is the gray one. And if you want to find out, hold on. If you want to find out this area here between the two graphs, I mean, it's pretty obvious what you do, right? You get the whole area, this entire thing here, underneath the F curve, right? All this thing minus this area right here underneath the G curve, this area right here. Okay, so in order to do that, what you have to do is do this. For example, you're going to be integrating from A to B. So it's the integral from A to B of f of x dx minus the integral from A to B of g of x dx. But because the limits of integration are the same, you can join these two, okay? So it's going to be just the integral from A to B of f of x minus g of x dx. That's it. It's pretty simple. So here we go. Got another. Okay, so how do we find this? What we want, I don't know if it's easy to see, what you want is this entire area here between these two graphs from x equals 0 all the way to x equal to 1. So you're going to have the integral from 0 to 1 of x squared plus 2, right, which is the f of x, minus the g of x, which is minus x. So minus x plus x. And then you have the dx. Okay, so integrating that, you're going to have x cubed divided by 3 plus 2x plus x squared divided by 2. And then you have to do from 0 to 1. You got to replace. If you're going to put a 0, you're going to zero all this out. Okay, so just worry about the 1. So you have 1/3 plus 2 plus 1 divided by 2. So let's check the minimum common denominator, which is 6. Going to be a 2 here plus 12 and plus 3 there, right? Okay. 14 plus 3 is 17. 17 over 6. Okay. Here's another example. Let me just erase all this. So 17 over 6 is going to be this area, right? This area right here. Just want to make it absolutely clear in the beginning what I'm talking about, this area right here. Okay. Everything inside here. Everything. This is 17 divided by 6. 17 sixths. Okay. All right, now let me erase that. Let's try another one. It's easy if you have the graph. I mean, given the functions, you could plot the graph yourself, but it's, you could plot the graph yourself, but it's easier if you have the graph. So we're going to be integrating, and it's dx, guys, because we're integrating with respect to x, right? You see these stripes in here? This stripe is going to become very thin. It's not going to be this width forever. You're going to add something, very small. All right? So you're going to have these stripes. You're going to be doing this all the way up there. Okay. You're going to be doing all these things all the way up there until you fill out the whole stuff. Well, anyway, the one on the top is going to be x. Okay, it'll be the integral of x equals minus 2 all the way to 1. And you want the this area here. So it's going to be 2 minus x squared. Okay, it'll be f of x minus g of x. So you got a minus x in here. This x is the g of x, right? And you want to do a dx. Let's do that. It's going to be 2x minus x cubed divided by 3 minus x squared divided by 2. And now you got to from minus 2 all the way to 1. So you got to do the 1 first. So it's going to be 2 minus, it's 1 cubed, right? So yeah, it doesn't really matter. So it's 1 cubed divided by 3 minus, first you got to put the 1, okay, and then you put the 2. So it's going to be minus 1 squared divided by 2, so it's going to be minus half, and then you got to do a minus, and it's good to open the parentheses here because you got to put the minus 2. So 2 times minus 2 is going to be, well, maybe we can already do it. 2 times minus 2 minus 4, but it's a minus. There's a minus. I'm going to do it the first time like this. Okay, let's go. Minus 4, okay. And here it's going to be minus 2 cubed. It'll be minus 8. With the minus plus 8, so plus 8 divided by 3, and then you have minus 2. Why? Because it's going to be minus 2 squared. It'll be 4. 4 divided by 2, 2. With this minus, minus. There you go. And now, because of this minus, you got to change the whole thing, right? It's going to be 2 minus 1/3 minus 1/2 plus 4 minus 8/3 plus 2. Okay, so let's see in here. I'm gonna put the I'm gonna take the minimum common denominator again of all this thing, which is gonna be 6. So it'll be 12 minus 2 minus 3. And then you have plus 24 minus 16, right? 6, yeah, and it'll be plus 12. Let's try to do this. You have 10 here, now you have 7. 7 plus 24, 31. 31 minus 16 is going to be 15. 15 plus 12 is 27. So 27 over 6. If I didn't make any mistakes in arithmetic. Oh yeah, I thought I had made a mistake, but I didn't. So this, you can simplify dividing everything by 2, right? By 3. And divided by 3 over 3. Well, you see, what I'm doing here is just dividing, right? Well, okay, let's just simplify. Instead of being a 6, it's going to be a 2. Instead of being a 27 by 3, it's going to be a 9. So this equals 9/2. Now, yeah, okay. Okay, so the sine and cosine curves intersect infinitely many times, bounding regions of equal areas, as shown in figure 7.7. Find the area of one of these regions. Okay, so the sine and cosine. So we have to find the boundary. Why? Because you're going to have sine like this, right? This is just a sketch. And then you're going to have a cosine that does something like that. I don't know, something like that. Okay? So what it wants is one of the areas between the bounding regions. For example, this one in here, just one of these areas. Okay? All right. So let's try for an x greater than or equal to 0 and less than or equal. You know, if it's going to be 360, it's going to be less than or equal to 360 degrees, okay? Or 2 pi. Let's just put 2 pi. Why? Because 2 pi equals 0, okay? 0 equals 2 pi. What? Yes, it is. You got to remember that this is a circle, okay? So you're going to be having these angles. So this is 0, right? 0 degree. And then you keep going, and then you have a 90 degree here. Keep going, blah, blah, blah. At this point, you're going to have something like this, which is 270. And then you keep going another 90 here, which is 360. So for the circle here, yes, 0 degrees equal 360 degrees. So the x is going to be greater than or equal to 0 and less than 2 pi. Okay? Because if it's less than or equal to 2 pi, it's just like, hey, but 0 is 2 pi, so it doesn't make too much sense. So we're just going to do this. Fine. We're going to find out where the sine and cosine are equal. Why? Because you want to find the bounding regions, okay? And the regions that are bound by the points where the two graphs intersect. So you want to find the bound region, the bounding regions. So we do sine of x equals cosine of x. All right. So you're gonna you divide everything by the cosine. So dividing everything by the cosine, you're gonna put the cosine here, dividing, and this is gonna be a 1 because it's cosine divided by cosine. So you have the tangent of x, which is 1. Okay. Now, in order to find this x in here, we do like the arc tangent of 1 is going to be equal to x. Okay. Now, for what values of x you have a tangent of 1? Well, you have, let's do it again, just for people that don't remember this trigonometric stuff. The tangent is the sine divided by the cosine, okay? So the sine divided by the cosine have to be equal. They're equal at 45 degrees, which is going to be pi divided by 4, okay? And for this part right here, 2, okay? So it's, I'm going to do this here. For this angle and for this angle here, right? So this angle here is pi divided by 4, and for this angle, I think it's 5 pi divided by 4. Yes, it is. Because you see, from, look at this, guys. In here, you have pi divided by 4, okay? But now, from here all the way to here, it's pi. So add pi divided by 4 plus pi. Put a 4 in here, put a 4 in here, equals 5 pi divided by 4. Okay. So, for pi divided by 4 and 5 pi divided by 4, okay? So the x is gonna be between these things, right? It'll be x is greater than or equal to this. Man, I'm gonna put the equal like that, and it's gonna be less than or equal. What a mess. Okay. I'll move it. It'll be less than or equal to that. Okay. The equals, okay, there you go. Fine. And then you go like, okay. Now what is the value of the cosine? Okay, the value of the cosine is the distance from this center here, this distance from this center to the thing, okay? So for example, at this point in here, what is going, you have this, right? What is the value of the cosine? Is this distance right here, And what is the value of the sine? It's this distance. Okay, so you can see that at 45 degrees, this distance and this distance are going to be the same. Okay, over here is going to be equal to this. I know it doesn't look equal, but it's equal, trust me. Fine. Now from here all the way to here, what is going to be the higher distance? It's going to be sine. So the sine is going to be greater than the cosine from here all the way to here. And you go like, okay, but what about at this point here, for example, here? Okay, is the sine greater than the cosine? Because this distance is greater than this distance, right? Look at this. You got a distance here, kind of like that, and you have this distance here. So which one is the greatest? This one here, look at the cursor, this one, or this one? This one is greater. Yeah, but in here it's negative, okay, because it's actually the displacement. In here you still have a positive sign, but over here you have a negative cosine. This is negative. So the cosine all over here at this half of the circle is going to be negative. So yes, from this point, from this angle, all the way to this angle right here, the sine is going to be greater. So you do sine of x minus the cosine of x, not the cosine of x minus the sine of x. And now I'm going to show you the graph of what I'm talking about. There. You see, the sine is the black one, the cosine is the gray. You can see that from pi divided by 4, which is this point, to 5 pi divided by 4, which is this point, the sine is on top. Okay, and the cosine is at the bottom. So we do sine of x minus cosine of x. Okay, so I'm not going to erase this. I'm going to erase this. I'm going to erase this thing here. That, and then this. Okay. All right. So it'll be the integral from pi divided by 4 to 5 pi divided by 4 of the sine of x. Because it's x, I'm not going to put it, okay? Just to simplify, okay, fine. Sine of x, sine of x minus cosine of x dx. Okay. Now what is the integral of the sine of x? It's minus cosine of x. Okay? It's going to be minus cosine of x minus the integral of the cosine of x is sine of x. Okay, and then you have to go from pi divided by 4 to 5 pi divided by 4. Okay, so let's do this. 5 pi divided by 4, the cosine is gonna be minus square root of 2 divided by 2. With the minus, it's square root of 2 divided by 2. Alright, and then you have this minus and the sine. The sine is also gonna be square root of 2 divided by 2 negative. With this negative is a positive. So square root of 2 plus square root of 2 divided by 2. That was for this. Okay? Alright, and now you got a minus. And we do it like that. So what is the cosine? The minus cosine of pi divided by 4. Well, you see, the cosine of pi divided by 4 is square root of 2 divided by 2 with this minus square root of 2 divided by 2. And then you have this minus here. Okay, and okay, let me just think one thing here. Yeah, cosine of one minus, this minus is going to be over here, and then you have the sinus of pi divided by 4, which is square root of 2 divided by 2. Square root of 2 divided by 2. So this here is going to be 2 square root of 2 divided by 2, which is just square root of 2. And then you have, here you're going to have minus square root of 2 with this minus plus square root of 2. So it's plus square root of 2 equals 2 square root of 2. So what is 2 square root of 2? It's gonna be this region in here, okay? 2 square root of 2 is the answer. And then you have this region here, okay? This region. Okay, and the blue too, okay? Because it seems that I'm avoiding the blue here. No, it's everywhere. This is the region. This is 2 square root of 2. Okay. Now, got another one here. Interesting. You see? In here, which one is the F is the black curve and the G is the gray curve. You can see that the F is on top from -2 all the way to 0. Okay, from x equals -2 to x equals 0. But from x equals 0 to x equals 2, then the gray one is on top. So you have to integrate twice. Okay. All right, and you can see on top here, f of x is greater than g of x for this part, and g of x is greater than f of x for this part. So let's do that. Let's integrate from -2 to 0. The f of x, it's going to be 3x squared, 3x cubed, minus x squared, minus 10x, okay? And then you have to do minus the other one. So it's going to be plus x squared minus 2x dx, okay? And then you do a plus. Yeah, this is going to be ugly. Do a plus the integral from 0 to 2, right? Yeah. The other way around. So it's going to be minus x squared plus 2x and minus 3x cubed minus x squared minus 10x. Oh, hold on. Minus 3x cubed plus x squared plus 10x dx. Yeah. Because the g is going to be on top, so minus x squared plus 2x minus 3x cubed plus x squared. You got to change the signs of the f of x plus 10x dx. Yeah. So let's do this thing here. In here you have a minus x squared plus x squared, so cancel this. Yeah. Okay. And minus 10x minus 2x is going to be minus 12x. So minus 12x. Bring the dx here. Okay. And in here's the same thing. You got a minus x squared with a plus x squared. So erase this. Erase this thing. Okay, and it's going to be a 12x minus 3x squared. Yeah, you see, you're just inverting the stuff. So I'm going to put the plus in here. I'm going to put this thing here. Erase this. So it's going to be the same thing but inverted. So it'll be minus 3x cubed plus 12x dx. All right, so let's do it. In here is going to be 3x to the fourth divided by 4 minus 12x squared divided by 2 minus 6x squared. Do that from minus 2 all the way to 0 plus and then we do this. It's gonna be minus 3x, what in x? X to the fourth divided by 4 plus 6x squared from 0 all the way to 2. Okay, so let's do that. Well, the 0 is just going to be a 0, right? When you plug 0 in here everywhere, you're going to get a 0. They have this minus, right? So minus 2. It'll be 16, minus 2 to the fourth, 16, divided by 4, 4 times 3, 12. But you got a minus, so you put minus 12. And then you have 4, 24, okay, yeah, minus 2 squared, 4 times 6, 24, with a minus, minus 24, with another minus, plus 24. And then you have a plus. Now in here, you don't have to worry about the 2, okay, because I'm going to do that. You don't have to worry about the 0 because it's just going to zero everything out. So in here is going to be the same thing, you know, 16 divided by 4, okay, minus 12, and 4 plus 24, okay. So you see, what you're going to have is minus 12 plus 24, 12, 12 plus. Here 24 minus 12 is 12, so the whole thing is 24. Now let's see. Yeah. 24. Now what is 24? 24 is the area, okay? And we're getting the area by doing this, right? We're integrating, so we're adding these infinitely narrow rectangles that look like straight lines, straight vertical lines. So it's this whole area, right? Plus this whole area here. That's 24. Okay. Now there's another one that's interesting. You see, on this one, we're integrating with respect to dy. Why do we want to do that? Because look at the f of y. Now we got an f of y, not f of x. So it's x equals y plus 1. Let's try to isolate the y. Y equals x minus 1. Great. What about the g of y? So we have x equals 3 minus y squared. So y is going to be plus or minus the square root, okay, of 3 minus x. So you see, you got to work with a plus or minus square root, and you go like, oh my god, which one of these are going to work? It's tough, okay? So you don't want to do that. Instead of you integrating this way, instead of you integrating this way, you integrate this way, okay? The bars now are going to be horizontal in the y direction. That's why it's dy, okay? And now you have x as a function of dy. So what do you have to do? Which one is it going to be first? Is it going to be f of y minus g of y or g of y minus f of y? Well, now you have to get, when it's like this, you want the top minus the bottom. But when it's like this, you want the right minus the left. Because what you're going to do is to integrate with respect to the g of y, you're going to get this whole thing, okay? You're going to get all this area here, all the way down there. Okay, and actually you're going to integrate all the way down here, okay? And then you have to get the f of y. Minus the f of y is going to be minus this thing here, okay? And then minus, well, actually you're going to add this thing because it's negative here. So it's easier. So we're going to do that. Because you see that if you're working with the g of y, isolating x, you don't have to work with a square root. Okay, so let me just see one thing here. Okay. We're going to integrate, and now it's dy, so where's y coming? You're going to look at this, minus 1, minus 2, you look at this minus 2, all the way to 1, because those are the limits for the y. So minus 2, all the way to 1, okay? And then it's the right curve. The right curve is 3 minus y squared minus the other curve, so it's going to be minus y minus 1 dy. Well, 3 minus 1 is just going to be 2. I'm going to do this here. I'll put a 2 here. Okay, let's integrate. It'll be 2y minus y cubed divided by 3 minus y squared divided by 2. And we're integrating, I'm going to put minus 2 and a 1. So it'll be 2 minus 1/3 minus 1/2 minus. And you put a 2, so it's going to be minus 4. And it'll be minus 8, right? With the minus plus 8 divided by 3. And putting a minus 2 here is going to be 4 divided by 2. 2 with a minus 2. This is just going to be a minus 6. I'm going to try to already make things easier here. Minus 6, right? So it'll be 2 minus 1/3 minus 1/2 plus 6 minus 8/3. I'm going to finish it up here. 6, it'll be 12 minus 6 divided by 3, 2 times 1, 2. I put a minus 6 divided by 2, 3 times 1, 3. And now I'm going to put a plus 6 divided by 1, 6 times 6, 36. And minus 6 divided by 3, 2 times 8, 16. So this is going to be 20. 20 minus 3, 17. 17 minus 2, 15. 15 plus 12, 27 over 6. And it's the same thing. You can simplify. Here is going to be 2, and this is going to be 9. So it's 9/2. I want to show something. Okay, it's 9/2. Now, here's the thing. I'm going to do this thing here. Let me just do this. Okay. So look at that. Okay, it's the same region. But now we're going to be integrating with respect to x to prove that it's the same size. Okay, look at that. It's the same size, but now instead of integrating with respect to y, we're going to integrate with respect to x. So remember, this stuff is 9/2. I'm going to erase everything, but yeah, I'm going to erase everything, and I'm going to say, hey, the previous exercise was 9/2. So if everything works out, we have to get to 9/2. I'm going to put the 9/2 in here. 9/2. Okay. Let's do that. Let me just... And I lost my place in here. Okay, that is the exercise. Then you have that. Oh yeah, there's something even more complicated that I want to show you, which is what I was saying. It's the plus or minus square root of 3 minus x. See, this graph right here is going to be y is equal to this. And this graph right here is going to be the minus y blah blah blah. So if you integrate, you can keep coming, right? Here up to here, it's one function. From here to there, it's another function, right? And the x is just going to be x. Don't have to worry about that. But here's the thing. You're going to be integrating blah, 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 blah. Okay? You're going to integrate, well, let me see. That's why it gets confusing. You're going to integrate all the way up to here, okay? Up to this point. And then you still have to integrate, because you see, I want to show you something that's another problem. When you're integrating all the way up here, okay, from this point all the way to this red line here, this one, what are you doing? What is the top one? The top one is this function, okay, and the bottom one is this function. But from this point right here of intersection and on, for example, blah, blah, what is the top function? The top function is this, and the bottom function is that one. So you have to change the functions too. That's why sometimes you want to graph the functions, examine the graph and say, hey, in order to find out the area of this, I think it'll be easier if I do this way than if I do that way. But let's do it, because I want to prove that's the same stuff. Okay? So looking at the graph, I'm going to look at the graph, do it here, and then I'll erase. So I'm going to integrate, we're integrating with respect to x, so it's going to be from -1 all the way to 2. Okay? -1 all the way to 2 of, what is the top function? Y is equal to x minus 1, so it's going to be x minus 1 minus the bottom function. And the bottom function is minus square root of 3 minus x. So minus minus plus, I'm going to put 3 minus x to the half, because it will just be easier. So I'm going to integrate that dx. And then you have to add a plus, and from 2 all the way to, gotta find out the coordinate at that point. When y is equal to 0, 0 is equal to, well, I'm going to put 0 is equal to 3 minus x, okay? So in order to make this 0, x has to be 3, okay? So from 2 all the way to 3, I have to do 3 minus x to the half minus 3 minus x to the half. So it's actually 2 in here, because it's going to be, right guys, it's going to be minus the same thing, so it's plus. So I'm just going to put a 2 here. Okay, dx. So let's do that. The first one, it'll be x squared divided by 2 minus x. In here, we're integrating this, so it's going to be 3 minus x to the 3 halves divided by 3 halves. So you're going to put a 2/3 in here, and divided by the derivative of the inner function, which is 3 minus x, it'll be -1. So I have to, I'm going to do this. Bring it over, erase this thing, put a minus in its place. Okay, so that is the integral, okay? Here, -1 all the way to 2, and then you have to add, let's do this, the integral of this stuff in here. It's going to be 2 times, because I'm taking this 2 out because it's just a constant, 2 times the integral, so let's do it. It'll be 3 minus x to the 3/2 divided, multiplied by 2/3. So I'm going to multiply this here by 2/3, okay? And also have to divide by the derivative of the inner one, so it's going to be a -1 in here. So this, whatever this is, it's going to be there's going to be a negative here multiplying this 2, okay? So it's like this, guys. I have to do this, and then I have to put a minus here. Well, this minus with this plus is going to become a minus, so I'm just going to put a minus here. Yeah, -2 times that stuff, okay? And I also have to do this from 2 all the way to 3. Well, let's do that now. Here you have 2, okay, -2, and then you have a minus. Now what's this gonna be? You have 3 minus 2, 1 times 2 divided by 2/3, so it's gonna be -2/3, okay? And then you have to put a minus. -1 squared divided by 2, so you got a half. -1 becomes a +1. And here you have 4. Okay, so what do you have? What's gonna happen here, guys? You see, it's a 4 to this. It's a 4 cubed. That's what it means. Put a 4 -1 in this x. 3 minus -1, 4. 4 to the 3/2. It's gonna be this. Okay, it's 64, so it's going to be 8, okay? It will be 8 times 2, 16. And there's something else here too. Yeah, you also have to work with plus or minus here, but I'm just going to work with a plus. Let's see if this works. So it'll be 8 times 2, 16. Divided by 3, 16/3 with a minus, going to be -16/3. Okay. And then you have the -2. I'm going to put it at the bottom. It's going to be a -2. Got to put a 3 here. So when I put a 3 here, this is going to be 0, blah, 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 it's 0. All right. So it's, you see, let's do this way so I'm not going to make any mistakes. This -2 is this -2. All right. And then when you plug in a 3 here, the whole thing is going to be 0. So let's just put a 0. And then you have another minus, and now I'm going to plug a 2. It's going to be 1, 2/3. Yeah. This is going to be 1 to the 3/2, 1 times 2, 2 divided by 3, 2/3. It's going to be 2/3 in here. Okay? All right. And now equals. And got to keep going. So 2 minus 2 equals 0. Forget about this. All right? And here you have, so you have -2/3. And over here you got a minus. I'm going to open the parentheses here. And then you have +4/3. Okay? In here, I'm going to put a 6. And it'll be 3 plus 6 minus 32. Right? 6 divided by the okay, minus 32. Okay, so now I can just multiply everything. I'm going to put a 6 in here, and I'm going to put a 4 here, and here I'm going to put a 6, and here I'm going to put an 8. Okay, so minus, well, let's do it. The whole thing is going to be a 6 in here, and now we do minus 4, right, minus 3, minus 6, plus 32, plus 8. Okay, so this is going to be 40. 40 minus 6, 34. 34 minus 3, 31. 31 minus 4, 27. So this is 27 over 6. And simplifying, dividing everything by 3, you got a 2 here and a 9 here. So it's 9 halves. Remember, 9 halves in here, and you got a 9 halves in here. So it's the same thing, but it was a lot more, it was a lot harder to set up the whole stuff, right? And I think it's easier to make mistakes because too many operations in here. And there's something else too. We considered when it was like, I considered, right? When I was doing this stuff in here, I put a minus 1 in this x. It was like 3 minus 1, 4 cubed, which is 64, and it's the square root of that. Well, it's plus or minus 8. I mean, what happens if you put a minus 8? Then if you put a minus 8 times this minus 2 is going to be 16, and so you got these problems. You want to avoid messing with plus or minus square root of something. If you can avoid that's good. Well, that'll be it for this video, guys, and I'll see you on the next one.